Imagine a world so far from the sun that daylight fades into a permanent twilight. A place where temperatures plunge colder than anything known on Earth, and where even the air itself freezes into solid ice. In this distant realm where the solar system becomes strange, silent, and alien, there exists a moon that defies every rule of nature. A moon that shouldn't behave the way it does. A moon that scientists still struggle to explain. This world orbits backward, spews geysers of frozen nitrogen dozens of kilometers into space, and may be hiding a vast ocean beneath its crust. This is Triton, Neptune's captured, impossible moon. And the deeper we look, the more mysterious it becomes. Before we dive into the frozen mysteries of Triton, make sure you hit that subscribe button and turn on notifications. That way you won't miss any of our journeys to the most fascinating and mysterious worlds in the solar system. In the mid-19th century, astronomy was undergoing a quiet revolution. Telescopes were growing larger, lenses clearer, and a new generation of sky watchers was beginning to push humanity's vision deeper into the cosmos than ever before. On September 23, 1846, that revolution reached a milestone. Neptune, the eighth planet from the Sun, was discovered not by accident but through mathematics. For the first time in history, a world had been found because its gravitational pull betrayed its existence. The scientific world buzzed with excitement. Newspapers wrote of a new giant beyond Uranus, and observatories across Europe scrambled to study this mysterious blue planet. Among those captivated by this discovery was William Lassell, an English brewer turned astronomer whose passion for the night sky had led him to build one of the most advanced reflecting telescopes of his time. Lassell wasted no time. Only 17 days after Neptune was identified, he turned his giant 24-inch telescope toward the distant planet, hoping to glimpse something more: rings, perhaps, or faint companions circling in the darkness. What he found was even more remarkable. On October 10, 1846, Lassell observed a tiny, pale point of light hugging close to Neptune. It moved with the planet as nights passed, revealing itself not as a star, but as a moon. This was Triton, discovered just weeks after Neptune itself. The discovery was astonishing. Finding a planet beyond Uranus was already a historic achievement, but to uncover its moon almost immediately afterward was nearly unbelievable. Lassell had revealed not just a new world, but the first piece of an even larger mystery. Even in the early years after its discovery, Triton refused to behave like an ordinary moon. Astronomers noticed clues subtle but unmistakable that something about it was different. Its orbit was strangely tilted, not aligned with Neptune's equator like most moons. Even more puzzling, Triton moved against Neptune's rotation. Though 19th century astronomers didn't yet have the tools to understand what that meant, they knew it was unusual. A backward or retrograde orbit was unheard of for a moon this large. Its estimated size also raised questions. Triton wasn't a tiny captured rock. It appeared to be a major body, large, dense, and bright. It reflected sunlight unusually well, suggesting an icy surface unlike the darker moons known around Jupiter or Saturn. These early hints whispered a larger truth. Triton did not seem to belong to the Neptunian system at all. It was as if Neptune had stolen it from somewhere else. Long before spacecraft ever reached the outer solar system, astronomers sensed that Triton was not simply another moon. It stood apart, mysterious, mismatched, and fundamentally different, a puzzle waiting for answers. From the moment Triton was discovered, its behavior puzzled astronomers. But it would take decades, well into the 20th century, before its strangest feature became undeniable. Triton does something almost no other large moon in the entire solar system does. It orbits backward, As telescopes improved and measurements grew more precise, scientists began to map the motion of Triton with increasing accuracy. What they found challenged every expectation. While most moons follow their planet's rotation, rising in the east and setting in the west just as Earth's moon does, Triton did the opposite. It traveled retrograde, moving west to east around Neptune, against the planet's spin. This was not a small deviation or a gentle tilt. Triton's orbit was dramatically different, inclined at a steep angle of about 157 degrees from Neptune's equator. In other words, Triton wasn't just a moon out of alignment. It was a moon running entirely in reverse, a cosmic rebel. And that raised a profound question. How does a moon end up orbiting backward? Natural satellites, those formed alongside their planets, tend to orbit in harmony with the rotation of the worlds they circle. Jupiter's Galilean moons, Saturn's Titan, even our own moon all follow this simple rule. They grow from the same swirling disk of gas and dust, inheriting the momentum of the system that formed them. But Triton broke the pattern. As the evidence accumulated, astronomers realized that Triton could not have formed around Neptune. Its size, its density, its orbital tilt, its retrograde motion, everything pointed toward one extraordinary conclusion. Triton was not born here. It was captured. Somewhere in the distant past, Triton was likely an independent world, a massive object from the Kuiper Belt, the same icy region where Pluto and many dwarf planets reside. Back then, Triton may have been part of a binary pair, two objects locked in mutual orbit, drifting far beyond Neptune's reach. But something changed. As this pair passed too close to Neptune, the giant planet's intense gravity tore the system apart. One partner was flung outward into deep space, while Triton was pulled inward, trapped forever by Neptune's gravity. In a moment that lasted only minutes, an entire world was stolen. But capture came at a cost. As Triton settled into its new orbit, tidal forces twisted and reshaped the moon. Its original orbit would have been chaotic, highly elliptical, and unstable. Over millions of years, energy was drained away as Triton flexed and heated from within, leaving behind the smooth, nearly circular orbit we see today. But its backward motion, that remained, a permanent reminder of its violent past. And there was another consequence, one far more dramatic. Triton's arrival may have destabilized Neptune's original moon system. Smaller moons would have been thrown into new orbits, or even ripped apart entirely. Some scientists believe Neptune's faint rings may be made of the rubble left behind from this ancient celestial collision. By the time Voyager 2 finally reached the Neptunian system in 1989, Triton's origin story had become one of astronomy's most compelling mysteries. A moon not formed by Neptune, but captured from the distant frontier of the solar system. Its strange orbit wasn't just a curiosity, it was a cosmic fingerprint pointing toward a past filled with violence, instability, and transformation. And that past would help explain the even greater mysteries Voyager was about to reveal. When Voyager 2 flew past Neptune in August 1989, humanity glimpsed Triton for the very first time up close. Before that moment, Triton had been just a faint, pale point of light in telescopes, mysterious, yes, but distant, cold, and largely unknowable. The spacecraft changed everything. As the images came back, scientists were stunned. Triton's surface was unlike anything seen elsewhere in the solar system. Vast, smooth plains stretched for hundreds of kilometers, broken only by jagged ridges and strange, lumpy formations nicknamed cantaloupe terrain, rounded, blistered patterns that seemed almost organic in texture. It was a world both familiar and alien, frozen solid, yet shaped by forces still active and dynamic. Voyager's cameras captured something even more surprising: cryovolcanism. Towering plumes of nitrogen gas and icy particles erupted dozens of kilometers into the thin, tenuous atmosphere. These geysers were powered not by magma as on Earth, but by sunlight. On Triton, even the feeblest warmth from the distant sun is enough to heat the dark winter surfaces, sublimating nitrogen ice into gas. Pressure builds beneath the crust until it bursts skyward, spraying frozen particles across the plains. These eruptions revealed a startling truth. Triton was geologically young. Its surface had been reshaped in the recent past, smoothing over ancient impact craters and refreshing landscapes that otherwise might have been billions of years old. In other words, despite its frigid temperatures around 235 degrees Celsius, Triton was not a dead world. It was alive in its own frozen, silent way. The moon's ice-covered surface was more than just nitrogen and methane. There were hints of water, ice, and carbon monoxide ices as well, forming a complex chemical landscape unlike anything on Earth or even other large moons. Some regions were incredibly reflective, bouncing nearly 70% of sunlight back into space, making Triton appear brilliantly bright despite its distance. Voyager also revealed long, linear ridges, clues of tectonic forces at work. The ice shell wasn't static. It flexed and fractured under the tidal influence of Neptune's gravity, a slow dance that reshaped mountains and valleys. These forces, combined with cryovolcanism, created a world that was simultaneously frozen and dynamic, a paradox that fascinated astronomers. Even the cantaloupe terrain remained mysterious. Scientists speculate it could be the result of convection within the ice, like boiling on a frozen scale, where warmer, softer layers rise through the crust and form the lumpy, mottled surface seen from space. Every new image and measurement hinted at a hidden world beneath the frost, a world still very much alive in ways we are only beginning to understand. Voyager 2's fleeting encounter lasted only hours, yet it forever changed our understanding of Triton. A moon that seemed distant, cold, and silent turned out to be a world of motion, energy, and hidden complexity. Its surface told the story of ancient violence, tidal reshaping, and ongoing activity, a story that no telescope could ever have revealed. Triton had arrived as a curiosity in 1846. By 1989, it had become one of the most extraordinary worlds in the solar system, a frozen frontier that was alive, mysterious, and utterly captivating. Voyager 2 revealed that Triton wasn't just an icy, geologically active moon, it also possessed a delicate, fleeting atmosphere, a whisper of air in a world where cold reigns supreme. Although it is only about 70,000 times thinner than Earth's atmosphere, it is remarkably complex for its size and distance from the Sun. The atmosphere is composed almost entirely of nitrogen, with trace amounts of methane. At first glance, such a thin layer might seem inconsequential, barely enough to stir even a wisp of wind. Yet, despite its tenuousness, Triton's atmosphere is active. It interacts with the surface, sublimating nitrogen ice, feeding the icy geysers, and even creating seasonal changes across the moon. Seasons on Triton are unlike anything on Earth. With a tilted orbit around a planet that itself orbits far from the Sun, Triton experiences extreme, decades-long seasons. One hemisphere bakes in faint sunlight for decades, slowly sublimating nitrogen and altering the surface pressure, while the other endures decades of near-complete darkness. This seasonal cycle drives winds, plumes, and ice migration, subtly reshaping the landscape over time. Interestingly, Triton's atmosphere is in many ways similar to Pluto's, another distant Kuiper Belt object. Both have nitrogen-dominated air, thin methane traces, and surfaces shaped by seasonal sublimation. But Triton's active geysers suggest a moon that is still geologically alive, whereas Pluto is more quiescent in comparison. Despite its fragility, Triton's atmosphere also holds secrets about the moon's interior. It reflects sunlight and transports heat, hinting at processes that extend far below the frozen surface. This thin layer of gas, almost invisible from Earth, is a living link between the surface, the interior, and the wider Neptunian system, a tenuous but vital breath of life in a world otherwise ruled by ice. Voyager's brief encounter gave us only a snapshot, yet it was enough to reveal that Triton's atmosphere is not a static shell of gas, but a dynamic, evolving layer whispering the ongoing story of a moon still very much alive, even in the farthest reaches of our solar system. Beneath Triton's icy crust lies a tantalizing mystery, one that could change our understanding of where life might exist in the solar system. For decades, scientists have speculated, could there be a hidden ocean beneath this frozen, distant moon? Evidence begins with the moon's geological activity. The smooth plains, cantaloupe terrain, and nitrogen geysers all suggest that Triton's interior is not entirely frozen. For these features to form, some source of internal heat is required. But how could a moon so far from the sun, where sunlight is a feeble glimmer, generate enough energy to reshape its surface? The answer lies in tidal heating. When Triton was captured from the Kuiper Belt billions of years ago, Neptune's powerful gravity stretched and twisted the moon, creating friction in its interior. That friction released heat, slowly warming the ice and possibly maintaining a liquid layer beneath the frozen surface. Even today, residual tidal forces continue to flex Triton's crust, providing a faint but persistent source of energy. Thermal models suggest that under the ice, conditions may be just right for a global subsurface ocean of water mixed with ammonia, which acts as an antifreeze, preventing it from freezing solid. This ocean may be dozens of kilometers deep, trapped beneath a shell of nitrogen and water ice tens of kilometers thick. The possibility of liquid water raises a tantalizing question. Could Triton harbor life? While surface temperatures are extreme and inhospitable, subsurface oceans and moons such as Europa and Enceladus show us that life can exist where heat, water, and chemical nutrients converge. On Triton, tidal heating, cryovolcanic activity, and chemical ices could create conditions that are potentially habitable, at least in the simplest forms of life. Voyager 2 gave us only glimpses of Triton's frozen exterior. But the hints of an ocean beneath, combined with its active surface, suggest that this distant moon is far more than a lifeless ice ball. It may be a dynamic, living world with an interior that hums quietly beneath a frozen, alien landscape. And if an ocean exists, it could also explain the geysers that still erupt from Triton's surface. Subsurface water or slushy mixtures could feed the nitrogen plumes, pushing icy particles miles into the thin atmosphere. Every eruption may be a window into the hidden world below, a glimpse of the moon's secret, concealed life. Triton's subsurface ocean is one of the most compelling reasons to return. While Voyager 2 revealed its beauty and strangeness, only a future mission can confirm the existence of this hidden ocean, map its depth, and perhaps even hint at the possibility of life in the coldest reaches of our solar system. Triton is more than just Neptune's largest moon. It is one of the most extraordinary worlds in the entire solar system. Its combination of size, retrograde orbit, geological activity, and possible subsurface ocean sets it apart from nearly every other moon or dwarf planet we know. When we compare Triton to other icy moons, its uniqueness becomes clear. Europa and Enceladus, moons of Jupiter and Saturn, also harbor subsurface oceans, but they orbit their planets in the normal prograde direction. Titan, Saturn's giant moon, has a thick atmosphere and lakes of liquid methane, but it is geologically slower and more stable. Triton combines the strangest elements of all these worlds: a captured object with the chaotic history of the Kuiper Belt, a dynamic icy surface, and a potentially habitable interior. Its capture from the Kuiper Belt is particularly significant. Triton provides scientists with a window into the distant outskirts of the solar system, a region largely untouched and preserved for billions of years. In many ways, Triton is like a frozen time capsule, revealing what worlds beyond Neptune looked like before the planets reshaped them. Its composition, orbit, and surface tell a story of planetary migration, cosmic collisions, and violent captures that shape not just Neptune's system, but the solar system as a whole. Triton also highlights the diversity of moons in the outer solar system. Unlike the more familiar moons of Jupiter and Saturn, which form from disks of gas around their planets, Triton shows us that some moons are wanderers, captured travelers from distant icy realms. This distinction makes Triton a key piece of the puzzle in understanding how planets acquire satellites, how objects move in the Kuiper Belt, and how extreme worlds can survive the harshest conditions. In short, Triton is a bridge between two worlds, part Kuiper Belt object, part Neptune moon. Its frozen surface, geysers, and possible ocean make it both familiar and alien, a reminder that the solar system is more diverse, more dynamic, and far stranger than we ever imagined. Voyager 2 gave humanity our first, and so far, only close-up glimpse of Triton in 1989. In just a few fleeting hours, it revealed a world of frozen plains, jagged ridges, nitrogen geysers, and tantalizing mysteries. Yet for all it taught us, so much remains unknown. How deep is the subsurface ocean? How active are the cryovolcanic plumes today? And could life in some form exist beneath that icy crust? The answer may come from future missions. One of the most promising proposals is NASA's Triton mission, a planned flyby of Triton designed to map the surface, study geysers, and search for signs of an interior ocean. Triton aims to investigate Triton's geology, measure its atmosphere, and understand the forces that continue to shape this extraordinary moon. Each instrument would provide insights that Voyager 2 could only hint at, revealing the processes that make Triton a living, dynamic world at the edge of our solar system. Returning to Triton is not just about science, it is about curiosity and discovery. Every icy plume, every smooth plain, every tilted ridge is a piece of a cosmic puzzle, telling the story of a moon that was captured, reshaped, and still whispers secrets across billions of kilometers. Triton is a world that challenges our understanding of how moons form, how planets evolve, and where life might find a foothold in the coldest, most remote corners of the solar system. As we plan our next journey, Triton stands as both a reminder and a promise that even at the very edge of the sun's warmth, the solar system holds wonders that are as mysterious as they are magnificent. The next mission may finally unveil its deepest secrets, and with them, we may gain a glimpse of worlds unlike any we have ever known. Triton is a world of contrasts. It is frozen yet alive, distant yet deeply connected to the history of our solar system. A moon that was stolen from the Kuiper Belt, captured by Neptune's gravity, and reshaped by forces both violent and subtle. Its retrograde orbit, nitrogen geysers, cantaloupe terrain, and possible subsurface ocean make it a world of paradoxes, a reminder that the cosmos rarely follows simple rules. For over 170 years, Triton has captivated astronomers from William Lassell's first telescope glimpses to Voyager 2's fleeting flyby. Each observation has only deepened the mystery, revealing a moon that is far more dynamic and complex than anyone could have imagined. Triton challenges our understanding of planetary formation, of what it means to be a moon, and even of where life might exist in the outer reaches of the solar system. Yet, despite the knowledge we have gained, Triton still holds secrets. Beneath its icy shell, in the dark waters of a hidden ocean, may lie answers to questions we have only just begun to ask. Its geysers may be the whispers of a world that is not silent, its surface the signature of processes we have yet to fully understand. Triton reminds us that exploration is never finished. The solar system is vast, mysterious, and filled with worlds waiting to surprise us. And at the edge of Neptune's orbit, Triton waits silent, distant, and enigmatic, beckoning humanity to return and uncover its deepest secrets. Because in the frozen darkness, where the sun is but a distant ember, Triton is alive with the story of the cosmos, a story that has only just begun to be told. If you're enjoying this journey to the edge of the solar system, hit that subscribe button and join us as we explore more mysterious worlds.